Alright, let's continue. Let me open the table of content first. Okay. We are still in chapter 26, concurrency and introduction. Let me open that. And well, we are in homework simulation section here. So let's take a look. This one. Let's continue exploring the README. Okay. What is it again? Thread info. Intro. Okay. I think this one. Now let's take a look at this race condition. This one, race condition with multiple thread. Okay, this is the instruction, I guess. The critical section here. Get the value at the trace 2000 and then put that in AX register and then increment that and then move it back from the register AX to the address 2000, the memory address 2000. See if we are still looping. Okay, if I remember correctly, this is checking if BX is 0, I guess, and if it is greater than 0, not considering the equal 1, we iterate again this one. So maybe we will stop when the value inside BX register here is 0. Maybe something like that. And then after that we halt. Right. The code has a critical section which loads the value of a variable at address 2000, then adds 1 to the value, then stores it back. Okay, the code after just decrement a loop counter in BX register here. Test if it is greater than or equal to 0. Oh, interesting. Is it also equal to 0? I mean, if I remember correctly, GGT is jump if greater than, not necessarily equal. I mean, if it is equal, we will use GTA here, right? Maybe there is a typo in here. I am not sure. Oh, maybe there is, but I don't think so. I mean, it is the same, right? GGT jump if greater than. So I'm not sure if we are also considering the equal to 0 in this case. And if so, jump back to the top, to the critical section again. Okay, looping. Okay, looping, there's no log here. This is the thread, if I remember correctly. The total thread that we use. Number of thread, I mean. This one. And then this is the what is it called? Initial value for the register. And this is the address, the memory address that we want to trace, or maybe track, something like that. And this one to compute the solution. Okay. That's it. Okay. Here you can see each thread run once, and it's updated the shared variable at address 2000 once, thus resulting in a count of two there. The hard the hard switch line is inserted whenever the thread halts and another thread must run. Oh, okay. Halt switch. This one. Whenever the thread halts and another thread must be run. One last example. Run the same thing above, but with a smaller interrupt frequency. Here is what that will look like. Interrupt. Okay. Oh, so that's what this I here means. I guess instead of, I'm still not sure if this is second or another measurement. Maybe instruction? Yeah, I'm not sure what 50 in here means. And this one is set in, right? It's in, but what does it do? Yeah, possibly in second, I guess. The interrupt in second. Every 2 seconds interrupt, maybe something like that. Okay, after this one, interrupt, right? Doing this again, which means the value haven't been updated, I assume. Haven't been moved back to the address 2000 here. And then there's another interrupt again. We move back the value from the register AX to memory address 2000. Subtract that, another interrupt. And well, this is the problem, I guess. We are replacing the previous, what is it called? The previous value in memory address 2000 with the value in register AX, I assume. Something like that. Interrupt again, this one. hard and hard. As you can see, each thread is interrupt every 2 instruction. Oh, every 2 instruction. So maybe the measurement for this flag, this I flag, means instruction. Is that it? But this doesn't look like 50 instruction. So here I'm not sure yet. Each thread is interrupt every 2 instruction as we specify via the -i2 flag here. What is the value of memory 2000 throughout this run? What it should have been? Now let's give a little more information on what can be simulated with this program. The full set of register AX, BX, CX, DX, and the program counter or PC. In this version, there is no support for a stack, nor are there call in return instruction, nor are there call and return instruction. The full set of instructions simulated are this one: move instruction with immediate, and then register, memory and register, register and register, register memory, immediate memory. Right. This is the information. Move immediate value to register, load from memory into register. This one and this one. Move value from one register to other. Store register content in memory. Store immediate value in memory. Okay, and then add, right? Okay, we add register plus immediate, register plus register, and then subtract register with immediate, register with register. And then there's test 2, compare immediate and register, set the condition code, same but register and immediate. Okay, register and register here. Jump if test has value, if test value are equal, are not equal, or equal here. If second is less than first, okay. If second is less than or equal, right? See, if the second, what is it called? Second value is greater than, not considering equal. The GGT, something like that, right? This one. And then GGTA, if the second value greater than or equal. Okay. Oh, there's also XGHG. Okay, interesting. Atomic exchange. Oh. Put value of register into memory. Return out content of memory into register to put things atomically. Oh, okay. So this is the atomic instruction, I guess. And then this one, no operation. notes immediate is something of the form $sign number here. I think we can think of this as a constant, maybe something like that. Immediate value. Memory is the form of number or reg here, or number, and then what is it called? Bracket. Reg. Yeah, this one is bracket reg. Do we need to use bracket though? Maybe. And then there's also this number with 2 register in the bracket as described above, and then the register is one of these register AX, BX, CX, and TX. Finally, here are the full set of options to the simulator are available with the test edge flag. Okay. Yeah, we can take a look at the source code, I guess. Most are obvious usage of this R turns a random interrupter from one integer frequency maybe, as specified by this I, turns on a random interrupter, which can make for more fun during homework problems. Okay, so there is random interrupt. But we need to, I assume, provide the integer frequency too, maybe. But then again, the default of interrupt, not integer. The interrupt frequency is 50, so there is that. Specify somewhere in the address space to load the code. Specify the size of the address space in kilobyte. Print some extra stat. Is not really used, unlike most simulator in the book. Use the tracing and condition code. Now you have the basic in place. Read the question at the end of the chapter to study this race condition and related issue in more depth. You know what? Let's try some of this. Probably this one. Yeah, let's try this first. Traits intro, okay. What is it again? I think there's P, right? Oh, not this P. Oh, this one. int.s. Okay. That's intro. Simple race. Okay. Oh, right. The default thread is 2. Okay. Let me check. difference using DESI or not. That doesn't look any different. I'm not really sure. Okay. Right. Is DESI have any effect? I am not sure. Okay. The argument is here specified. Okay. The output is easy to read. Okay. Oh, maybe we need to use the trace. What memory? 2000. Oh, wait a minute. Why is it different? 2000, but this one using the PX. Interesting. Well, let me try. Okay, there's question mark here. Oh, okay. Yeah, maybe we need some kind of trace to make the compute have any effect, I guess. Also register trace here. Okay, AX and PX, I guess. Oops, forgot the DESI flag, which actually computes the answer for you. Okay. Alright. Okay, interesting. Hello, Chris. Okay. Welcome. Hey bro, how is the journey going? Still fine, I guess. I mean, I'm still on the concurrency part, still on the introduction about concurrency, so it's still on progress, I guess. Now I'm trying to understand about this simulation. What the simulation do? Something like that. Okay. So I assume this is the initial value in the memory address 2000, and and then register AX, I mean, and then register PX, maybe. Okay. Yeah, I'm kind of curious. What about he add some initial value here? AX, let's see, 1 and then PX 1. Oh, must be 1 per thread. Okay, it looks like I forgot the, what is it called? The format, like this one. If you're using comma, it is per thread argument, and if you're using colon here, it means what is it called? For one thread. So because we only have one thread here, in this case, right, that means we need to use colon, something like this. Okay. Oh, interesting. The initial value here, initial value in the address 2000 is 0, and then initial value in register AX is 1, initial value in register PX is 1, and then we move, what is it called? We move the value from register 2000 to this one, to the register AX. That's why there is a change to 0 here, and then add 1 to the value of AX, of register AX, and then we move back this value. Okay. Now, yeah, what is the point of this? I still didn't understand. Do we need that? Maybe. Okay. Let's see. I have tool here. Okay. Yeah, it looks like we didn't use the value in register PX. Maybe something like that. Okay. Alright, now let's try using second thread. Yeah, looks like we are not using the value of PX here. Okay. Yeah, I'm still not sure about this bracket register. Is it like what is it? Using the address maybe, but which address? Is it the address in the register PX? like the pointer, pointer saving the address, right? Or the address of the px itself. Again, similar to the pointer, but instead of the address inside this pointer, we use the address of the pointer itself. Is that the case? I'm still not sure. I still need to understand more of the assembly here. Anyway, okay. In this case, there is no problem because we are already moving back the, what is it called? The result from AX to PA to memory trace 2000 here, I mean. So there is no problem there. But if we change, let's say, the interrupt frequency to B2, like the previous, what is it? Yeah, like this example. Every 2 instruction, something like that. There will be some problem. See, the value in the register AX still 1, because again we already add the value and then we context switch, which means we save the value in the AX register here and then load the new value for the thread 1 here and then add that again, right? But then we have another interrupt, which what is it called? Which move back the value from the previous thread register, the AX register, into the 2000 memory trace. And then the problem is that the thread 1 replacing the previous, what is it called? The previous value in the memory 2000 with its own value in the register AX, right? That's why the value in the register AX here did not increase or something like that. It is kind of the same with this one, We are replacing the initial value in the register AX with is 1, right? With the value from address 2000 with is 0. And well, I guess we can also do this. Is this only for register? Or maybe we can use the memory address like this. I'm not sure if we can do this. No, we cannot. Okay, looks like we cannot do that. Yeah, that make me curious. Is there any support for, what is it called? For having the initial value in the memory address here, or it needs to be 0. I am still not sure. Maybe we can do that with the assembly. Maybe. Okay. if we do that with assembly, I think we can do something like this. Oh. Why did I change the right file? Oh. Wait a minute, why this is still 0? Maybe I should do this. Okay, that is interesting. Now we have a new value here too, right? It is from this immediate value or constant. But the thing is that why doing it like this didn't work? Maybe because this is the offset from the px, but then why we add px here? What is the reason there? Let me try. Yeah, I don't really see any reason why we use something like this. I'm still not sure. Like when we need to add the px here, I know that, what is it called? The register px is base, I guess, and the 2000 is offset. But then why didn't we just do this? Move the value in the memory trace 2000 into AX, into the register AX, without having PX as the base. I am still not sure. In the readme, right? In the readme, that is the example being used. So I'm not really sure. See, this is the example being used, right? Which is kind of different from this one. Yeah, I'm not really sure. Maybe do it that way. Okay, this one, the number is the address, content of register, in parentheses forms the address. Okay, again the number plus content of the register from the address, right? Basically, what this is called, in this case something like this. I'm still not sure content of the register here. Again, it is something like the pointer maybe. So maybe we have the address value inside this register, and then we access that address at the reference. Is that the case? I am not sure. So here we set the, what is it called? In this case we set the initial value, or we change, I guess, initial value of 2000, initial value of memory address 2000 into 2 instead of 0, and then we replace the value. Oh, interesting. Okay, we replace the value from memory address 2000 plus px memory address, which in this case it is still 0. See, there is a difference here. Moving the value from memory address 2000, which we just recently changed, right? And then we move that into register AAX here, count 2. Oh, interesting. But why this didn't work? You know what, let's change this to maybe 3. Oh, ho ho ho. Ho ho ho. Okay. The value in memory address 2000 here did not change, but the memory address, what is it called? 2000 plus px address, I guess. Well, I'm still not sure if it is the register address itself or the address inside of the register. Maybe the question is something like this. Means the address of but then again, is register having any kind of address, like the memory address representation? I'm kind of curious. Of the register or the address in the register. How can a register have an address? Register is a place in CPU with small storage space. Okay, 16-bit on 16-bit CPU. The CPU register have address, and how are we able to add displacement to it if it not in memory but on CPU? This is the Intel syntax, if I understand correctly. And in this case, we are using AT&T, or maybe INT syntax, something like that. There is some difference there. You are adding displacement to the memory address contained inside PX. You are not moving, okay. 1000 X byte from the register PX. Normally registers don't have a memory address, but some do. Okay. For example, the stack pointer SP in AVR microcontroller. Oh. Let me copy this in the chat in case anyone wants to take a look. x86 registers are only ever addressed by name. The expression, this one simply means the value in register PX plus. Oh. And the result is interpreted as an address into memory. Okay. Via the square bracket here notation, not into some register space. The overall interpretation of the expression is load into AX the 16-bit located 1000 byte after the address PX point to. After the address PX point to. So maybe PX is the pointer. So we have a memory address as the value in the PX. Okay. So does that mean when we change the PX, what is it called? The PX value to be 2, does that mean we are putting, what is it called? We are putting the value in memory address 2002 rather than 2000. You know, that make me curious. Okay, let's try this. Okay. All right. See, we are changing that. Compare that to this one. Okay. All right. So that does not necessarily a memory address, maybe. It can be anything, I guess. So maybe the right question is, what is 1000 means? It means value in register into, yeah, I'm gonna call that any value into 2000 memory address and treat the result as memory address. Let me put this as the reference, I guess. Okay, reference. Okay, so there is some effect if we change the value in the px register here. Okay, for example, something like this, right? See, we didn't change the value in memory address 2000, but we change the value, what is it called? In memory address 2002. Okay, maybe something like this. Px equal 0, right? And then 2000 px move 3000 px. It means that we are moving in immediate value or constant value into address 2000 here. But if we change the px into 2, something like this, this will become something like this. I assume that is what it means. Maybe. Alright. Yeah, that's why the value in the memory address 2000 has not changed at all. And then in this case we are replacing what is it called? Replacing the value in the register AX, something like that. Okay, that is for the simple trace there. Okay. Is there any? Yeah, maybe let's try. I'm not sure, maybe we should keep taking the simple race or not. You know what, maybe let's try the simple race with another scenario, I guess. I mean, for example, like the thread, instead of 1 using 2 and then using the interrupt frequency here, for example. So let's try another scenario with simple race. on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.